Okay, ladies and gentlemen, in functions, I just realized that I've been recording videos without audio, so I will redo some videos later today. Go ahead and hit pause and do this warm-up, and we'll go over it. Okay, so this first one, so you should have gotten 4, because 3 to the 4th power is equal to 81. You should have gotten negative 3, because 9 to the negative 3rd power is 1 over 9 cubed, which is going to be equal to 1 over 729. All right, this one was hard. So the way that I thought about this one was that 81, I wanted to get it down to 3. If I get it down to 3, then I need to think about how, the reason why I want to get to 3, because 3 cubed is 27, so I need to take the 4th root of 81, so I need to take 81, and whenever I'm thinking roots, I always have to think of the exponential power of that. So 81 to the 1/4, and then I want to cube whatever that answer is. So then you take right here, so I have the 4th root of 81 cubed, so it's like looking at those problems we did in the last unit, but working our way backwards, which gives me 1 over 4, right here, 1 over 4 to the 3rd power. Well, when you take a power to a power, you multiply. So the answer is x is going to be equal to 3 divided by 4, 3 over 4. So if you have any questions on that, please let me know. Otherwise, go ahead and make sure you get that in your notes. Okay, Euler's number. Euler's kind of a big deal. It's kind of a huge celebrity. So he was a huge contributor to the mathematics that we use. You've got the Euler Circuit. You've got different things. This E minus K plus F equals 2. It's a big thing that comes up in calculus, beyond Calc 2. I'm trying to think of all the different things, but it's everywhere. So we're going to use that. When we think of that, we have log base 10, which is just log. So if you see just log, it is implied that it's log base 10. That's our common log. And then right here I have something that you need to know, that log of 10 equals 1. Then you have natural log, which is log base E. So when you do natural log of E, that also equals 1. So that's something that you want to be thinking about. That's something that you want to have in your notes, because it's going to keep coming up. Comes up in Calc 1, comes up in Calc 2. You're going to see it a lot on the calculator. So if you wanted to do E, you would do second and that division sign, and then you would hit enter, and it would just give you the number. So E is a lot like pi, whereas pi is just an irrational number, so is E. The other one that you'll use a lot is this caret. So you'll do, you can just use the caret and it'll give you any power you want to do. Here are your log buttons over here by the 7 and the 4. So you'll use those a lot. All right, here is 3 things that I want you to write down. So something that I do want you to note is that this equals 1. I wish my pen would just work. So b raised to the log of b, or log base b, is equal to 1. That's a 1. Up here, as you can see, you have that up here as well. So we've got b to the log of b of x is going to be equal to x. You don't really need this right here. And then you have log base b of x. Now this is something we can rewrite, right? We know how to do this. Log base b of b is equal to 1. Because remember, anything... All right. Make sure you get that in your notes, and that is something that, but this part right here is something that I am going to ask you to memorize, that b to the log of b, log base b is 1. Please memorize that. Okay, so we're going to use some special properties, and we're going to try this out. So one of the things that we're going to do is log base 10, which I could have just written log, but I didn't. Log base 10 of 10 to the 5th. So log base 10 of 10 simplifies down to 1. We can apply the power rule first, which we already know. So we end up with 5 times log base 10 of 10, which gives us 5 times 1, which is just 5. So if you have any questions on that, please let me know. All right, so we have log base 2 of 8. Now, a lot of us in class were able to jump to, that's 3. But here's why it's 3. So we can rewrite that as log base 2. So we can write 8 as a base of 2 in that answer part, in the second part. And if we're able to do that, we should. Then we can apply the power rule. We have 3 times log base 2 of 2, and log base 2 of 2 simplifies down to 1, and we end up with just 3. So there's a couple different ways. If you know that 2 to the third power equals 8, you don't need to redo this, but this practice, this writing it down so you can see it when you know what it is, will help us later on when we don't know what it is. All right, we have 5 to the log base 5 of 9. Well, this right here is just going to turn into a 1, and we are left with 9. All right, so make sure you get those in. Last week I gave these rules, so we covered the product rule, the quotient rule, and the power rule on Friday. If you watch that video, there's probably no audio, but you can go ahead and get those these rules in now, and then I will go back and re-record that video and reattach it. I didn't realize I wasn't recording with audio. Didn't realize my mic was muted. Such a rookie teacher virtual thing to do. Sorry about that. Okay, so make sure you hit pause and get these rules in here. Okay, so now we're going to use properties to write. So this is where we're going to be expanding logarithms and compressing. We're going to make them big and small and go back and forth and use all the rules. So the first thing we want to do is we're going to look at this log base 6 of 36 of m to the 5th times m to the 5th. So let's rewrite that and let's use the product rule. And I'm rewriting it with the product rule because I have 36 times m to the 5th. Then I can rewrite 36, log base 6 of 36, and I can use the power rule here. So I get log base 6 of 6 to the 2nd. So remember how I said if we can, we should rewrite this as a power or as a base of 6, and I can. So this is going to turn into a 1, and I'm just left with 2 here, and then I'm going to apply the power rule and throw that out front. So I end up with 2 plus 5 times log base 6 of m, and then I'm done. Again, we have log base 2 of the square root of 9z. Make sure you get this in your notes. First thing I want to do is I want to rewrite the radical as an exponent. So then I get log base 2 of 9z to the 1/2. Notice that I have this in parentheses. I have this in parentheses because all of this is underneath the radical. So it belongs to both of them. That was something that was missed on the test. So make sure that's something that we're noting here. So then I can now apply the product rule. So I have log base 2 of 9 to the 1/2 plus log base 2 of z to the 1/2. So I've used that product rule. Now I'm going to use the power rule, which means I'm going to throw the power out front. Then I'm going to rewrite as a smaller base. So I'm not able to rewrite 9 as a base of 2, but I am able to rewrite 9 as a base of 3 to the 2nd power, which will help me simplify it that much further. And then when I do that, I get 1/2 times 2, because I did the power rule again. And then I'm going to go ahead and multiply. What is 1/2 times 2? Well, that's just 1. So I end up with log base. Oh, you guys can't read that because my screen. Let me see if I can make it bigger. There it is. So now you get log base 2 of 3 plus 1/2 log base 2 of z. So again, this one was simplified pretty much at the beginning. It didn't go any further, but this side changed a lot. All right, let's do some more. Okay, now we're going to apply the quotient rule. And the reason why I know that is because I've got division. So remember, it's the numerator, log base q of the numerator minus log base q of the denominator. So that's what I have, the quotient rule. So there's that minus sign, it goes right here. There's the numerator, there's the denominator. Now we don't know of any rules, there aren't any logarithmic rules that say that we can do anything with this m minus 1. So this log base q of m minus 1, that one's done. We're just going to keep messing with it. But this says we can do something. We can do 8 times r squared. There's probably 2 rules right there that we can apply. So the first thing we're going to do is apply the product rule. So that product rule says that I can break this up with a plus sign. And then I want to apply the power rule. And then I'm done. So I have log base q of 8 plus 2 times log base q of r minus log base q of m minus 1. Make sure you get that in your notes. All right, now we're going to start expanded and we're going to go backwards. So the first thing I want to do is apply the power rule. I want to do the reverse power rule, which is going to make the 2 and the 3 into exponents right here. So the 2 moved back here and the 3 moved here. So I did the reverse power rule, and then I want to do the product rule, which says that I'm going to multiply these if I'm adding them. And then that's as far as we can go. And then our last example is log base 4 of 3x plus y, which there aren't any properties of logarithms to rewrite as a sum. So we are done with that one. That one can't go any further. So being able to recognize when you can't go any further is also really big. This is as far as we got today. If you have any questions, please let me know. Otherwise, I will see you all tomorrow. Also, part 1 of your homework is due tonight. You can start part 2. That'll be due next week. Don't forget the test is on March 4th. We are taking this test next Friday.